Have you ever wondered how a truck loaded with 40 tons manages to stop in the middle of a steep descent without relying solely on the driver's physical strength? The secret doesn't lie in common metal discs like those in a passenger car, but in an invisible, powerful system that works exactly the opposite of what you'd expect. Unlike your vehicle, where the pedal pushes the brake, on a truck, constant air pressure is required just to keep the wheels released and ready to roll. This creates a fail-safe mechanism. If there is a total air leak in the system, the truck doesn't lose its brakes. It locks the wheels instantly and stops right where it is. This whole process begins at the air compressor, a mechanical pump linked to the engine that works nonstop to keep the entire system pressurized and ready for action. This compressed air is sent to reinforced steel tanks under the chassis, acting as air storage reservoirs, ensuring immediate energy whenever the driver hits the pedal. The real engineering magic happens when that air reaches the wheels, where massive components must handle extreme temperatures and constant friction during braking. Unlike small discs, the drum system offers a much larger contact area, which is vital for dissipating the heat generated by dozens of tons in motion. When the driver presses the pedal, the released air rotates an S-shaped camshaft, known as the S-cam, which forces the brake shoes apart. This simple, yet genius mechanical leverage converts air pressure into tons of physical force, squeezing the friction material against the metal until movement ceases. To prevent the system from overheating on long descents, drivers use the engine brake, turning the engine itself into a powerful braking system. By blocking the exhaust gas outlet, the engine creates a physical barrier that slows the wheels without wearing down or heating up the main brake linings. In the mountains, the sound of escaping air we hear is the relief valve working, ensuring that the internal pressure in the tanks always stays within safety limits. There is also the slack adjuster, a critical component that automatically calibrates the distance between the lining and the drum to ensure the brake always responds immediately. Without this constant fine-tuning, the system's response time would be too slow, making it impossible to stop a vehicle of this size in a real emergency. In the rear wheels, the so-called double chambers house a giant emergency spring that remains compressed and hidden, waiting for the moment to save lives. If the air pressure happens to drop below the safety level, this spring overcomes the resistance and locks the wheels mechanically and completely. Understanding the air brake system is realizing that these highway giants only move forward because a complex pressure system is keeping the safety springs tamed. The next time you pass one of them, you'll know that behind those giant wheels lies one of the most brilliant and reliable safety solutions ever created by engineering. Every valve and every piston was designed so that, in the event of any failure, the final result is always the protection of life and the total immobilization of the vehicle. Thanks for watching. We are the Exposed Engineering. Subscribe for more.